This is for Year 12 methods. It comes out of Chapter 9, it's 5.9, question 2p. It's using the quotient rule to take the derivative of the square root of x divided by tan of x. Remembering for our quotient rule that this is the derivative of d dx of u on v. That's going to equal v times the derivative of u minus u times the derivative of v all over v squared. So in this particular case, u equals the square root of x, which is x to the 1/2, which means u dash equals 1/2 x to the negative 1/2. And v equals tan of x, and v dash will equal sec squared of x, or 1 on cos squared of x. Okay, so putting that together then, d dx of the square root of x on tan of x will equal v u dash minus u v dash all on v squared. V is tan of x, u dash is 1/2, so I'm going to put 1/2 x to the negative 1/2 times the tan of x minus u, which is that, so x to the 1/2 times v dash, which is 1 on cos squared of x, all on top of tan squared of x. Okay, taking out common factors, I need to simplify this. I have a half, so I'm going to take a half out. I have x to the negative 1/2 and x to the positive 1/2, so the smallest power is negative 1/2, and I take that out. The half goes out, the x to the negative 1/2 goes out, that leaves the tan of x. Minus x to the negative 1/2 went out, so that leaves an x. The half went out, so that means I have a 2 inside there, because a half times 2 gives 1. And that's going to be over cos squared of x, and all of that is over tan squared of x. With the half, the 2 goes down the bottom. With x to the negative 1/2, that goes down the bottom to become root x. I'm going to rewrite tan squared of x as the sine squared of x on top of the cos squared of x. I'm left on the top with tan of x, which is the sine of x on the cos of x, minus 2x cos squared of x. This is on cos x, this is on cos squared x, this is on cos squared x. I'd like to put everything on top of cos squared of x. So I'm going to have the sine of x cos of x on cos squared of x, minus 2x on top of cos squared of x, all on top of 2 root x sine squared x, all on top of cos squared of x. I can take out a common factor of 1 on cos squared of x from the top and the bottom, which means I'm then left with sine of x cos of x minus 2x, all on top of 2 root x sine squared x, and that's my answer for the derivative in simplified form.